So we have. So we're bringing the meeting to order. This is the July 9th meeting of DSAC, 2025. We have Charlie online, Jennifer Field, Brent Kozlowski, David Hackelman, Dave Livesay, thank you. I'll get there. Peterson?
Yes.
Peterson, Chuck Gilbert and Robert Kipper. This is kind of we're in an unusual place this time because downstairs an expansion public hearing is happening at the same time. So I'm not anticipating we'll have much public comment in this meeting, but we can hop straight in. Is there anyone online?
No.
All right, so maybe this will be a short meeting and then we can all hop downstairs and go see where all the action is. Speaking of which, I thought we could spend a few minutes just getting an update on where the expansion proposal stands right now. Bailey, do you want to give us a quick update on where things are at?
Yeah, as you know, the hearings are continuing. Last night was the latest of them. I saw you there, and it was the staff report. The staff report ended up being in favor of permitting the expansion. That lasted a good chunk of the meeting, followed by planning commissioners' questions of staff and the consultant. And then afterwards, Republic gave a briefer overview, and then the commissioners asked questions of them, and by then it was 10, so they decided to postpone the public comment until tonight. I would expect tonight's going to go late as well.
I did have a question about it. I was wondering, is there like a main reason why the staff reversed their decision? And because they initially were not in favor of the expansion.
Yeah, it was based on follow-up supplemental information that Republic Services provided. I personally wasn't involved in that part of things, so I don't have a lot more to tell about that.
You know, it was conditional too. There's 85 conditions.
Yes, yeah.
So.
Okay.
Yep. And it could be that those conditions would be of interest to the group as they pertain to your respective committees.
Were they listed? Or
there's a document. It's online. If you'd like, I could send that out.
Or it's on the DSAC?
I think you sent it out to us already.
Did I? Okay.
Yeah, when I sent out I think I forwarded, you know, 2 weeks ago, and attached the staff report to that email for us.
Right. And they didn't discuss any of those points last night, I guess is what we're leaving them.
They Republic Services brought up a couple of the items and wanted changes to them, but they didn't go through it in a lot of detail.
Yeah, I was just curious if some of those points deal with current operations that might affect what we think about how they're managed.
Yeah. I do have 2 other quick updates but I don't want to, if they're.
I have a follow-up question on the conditions, because I tried to go through all, that was a lot of reading there. I went through them looking for kind of new conditions that would really change much, like a tonnage cap, for example. I didn't see that one in there.
Right.
And the other conditions that I was reviewing it this afternoon, and they looked like they were just kind of consistent with standard operational procedures. Was there any
monitoring?
Was there anything like
with no penalty?
Yeah, I saw that. Is there anything new or like, all right, we're gonna condition the heck out of this thing, and condition 1 is a cap on tonnage. Condition 2 is, you know, whatever. I didn't see anything substantial in there. But I read it for 2 hours. So
yeah,
there was the organic cap, which was I think 900,000 for organic material, which
like biochar or something.
Which is supposedly related to odor.
Yeah.
And then there was some debate on, okay, was that gonna affect the overall, how does that affect the overall cap based on, loads and what you get? And that wasn't very clear to me.
In my opinion, this is just me
Yeah.
doing back of the napkin kind of calculations, and organics are close to 50%, like 49 point something percent of what's in the landfill. And so if the cap is gonna be 930,000 tons of organics, then that would one would assume then that they're essentially gonna double the amount of garbage coming. If they wanted to get as much organic, if they just take things as it is and they stay at that 930,000 tons, then that would imply that
The
up to
opportunity to double.
2 million pounds are gonna come.
Just to pause for a second,
Thoughts?
Bailey, Charlie, can you see us at all, or are you just seeing Bailey?
I can only see Bailey. I don't see the group. And for a minute there, you just popped in, but I sort of see this like the galaxy kind of look. That's a little, they showed up for a minute there.
Maybe, Bailey, can you turn off the background? Maybe that's blurring, it's just catching the person in the foreground.
Just background. None.
Or, yeah, a virtual background.
Yeah, left, top
Done, we're just
left,
done.
there's one that says none right below your
It's
cursor.
already
Oh,
highlighted, but if you
that
go
one.
to the,
Sorry, no, virtual background,
yeah, go to the virtual backgrounds tab.
that's it, none.
There we
Oh,
go.
There you are.
I've been struggling with trying to figure this out. This morning Chuck came and I was like, why isn't that one working? Thank you.
Okay,
I do have two quick other updates. One is, if you recall, Paul Neatfield came and gave a presentation about looking at, the money that's come in and then kind of backwards casting, looking at the, amount of tons then that represents, and, things are on track. So, thanks to Paul for bringing that to, it'll be a good tool for me going forward. One other update is July 1st, the Recycling Modernization Act came into effect, and so we have these updated list of what's accepted. And if you have recycling questions, you can always check out.
so are these actually recycled? Like, is there a gap between what's accepted and what's actually recycled, or is like, this is all recycled?
Oh, that's a good-
I'm not sure I
This is-
understand.
Well, this is what's mandated by law, right? By law, all this has to be accepted as recycling, but I'm wondering whether it is
Where
actually all
it's-
recycled.
Is it actually?
Oh, yeah.
Public take it.
Yes,
Now, who?
Republic takes it,
Whoever
but
takes it.
whoever takes
Yes.
it, then.
that's a big part of the Recycling Modernization Act, is being sure that the end markets are going to certified, they're certifying the processors and being sure that the end markets are good, yeah.
Oh, this
And
goes-
can I just say something? If I read that correctly, there were some things that required that there was some specific, the company, like, for example, aluminum foil is not accepted.
It is now.
No, it's only accepted by the manufacturer or something. It's
Yeah.
not like taken by Republic Services. It's not
It
supposed to
is-
go in there. If you look
It
at
is
that,
now, it's okay.
oh, it is now?
It is now,
It's
yeah,
not listed there, Bailey, it just
It's
says
aluminum
aluminum
steel cans, it doesn't.
yeah,
scrap.
well, that needs to be, and also empty aerosol cans are another one, but that'll get updated,
Okay,
yeah.
Well, would it be appropriate for us to ask where all of these things are taken by Republic?
if you want to, I mean, it goes currently to Pioneer Recycling up in Portland. And from there, they separate it all out into plastics or paper or cardboard or
They
whatever.
just take a big barrel of it and dump it in the ocean, the plastics, and it makes an island.
Um,
Bad attitude.
yeah, so, yeah, you could certainly ask them, where,
Well, I guess the question is like, who, is the state monitoring Pioneer? Like, who's making sure that they're them doing, that's the state?
yeah, and they get audited and.
Yeah.
Yeah,
But will the entire state's recycling all go to that one particular company?
there are about 10 of them, and most of them are in the Portland area. There's one in Salem.
I just wanna know what the material from our area, where it goes, and then we can follow it from there.
Yeah,
Say that's Pioneer and Portland.
But,
probably soon to be Salem, but
But they don't record it where it's coming from, so for instance. If it's coming all from Benton County, do they record it like landfills do, or do they just get it in mass and so?
it's a big, complicated report that they do every year where they track all of the recycling and where it's going, and as well as all the garbage. And then they follow up with those companies that are receiving it, and they are required to say where they're receiving the material from, how many tons, and yeah, that gets included in the annual opportunity to recycle report.
Oh, you know, what my question is really, cause we're the disposal site advisory committee, so I wanna know where it's not going, okay, because if it's recycling, then it should not be going to the landfill. Okay, that's kind of what I'm asking,
Mhm.
and that's kind of what I'd like the public to let us know. Beyond that, we're not the recycling committee if there is one. So that's another scope that one could pursue, but probably not us.
Well, I think another question to ask is, you know, we've got, this looks like full circle, you know, when I think back. 25, 30 years ago, recycling everything went in, including scrap metal, and then they said, no, we're not taking it because we can't find markets for it. So this modernization act say you have to take it, if you can't find a buyer, you have to pay to get rid of it. Meaning is, there's some people supplementing that, saying, well, take this recycling, we'll give you money to take it. It's kind of like our electronics recycling, some of that subsidized by your garbage bill, where, you know, they say, well, recycle electronics, that goes to a company in Washington, from what I understand. And then that's also paid by Republic, saying, okay, you're gonna take stuff for free, we're gonna pay you to take it. So that's, I think, another question to ask is what is this gonna do to the consumer's garbage bill? And if you can't find, you know, open markets for it, okay, well, we'll do something with it, you gotta pay us to do it.
So part of the RMA, and I actually did a presentation about it today that was recorded. I did one yesterday too, that was also recorded, so I could send those if it's helpful. But there is something in the RMA that addresses the market issues, so that when markets for any particular commodity dip too low, there's a fund set aside to kind of bridge that gap until the market stabilize again. That's also why they've been reluctant to put some things on the list, like clamshells being a big one. Because they want to be sure that the markets are solid enough before they give the approval for people to start putting those in. So market development's part of the Recycling Modernization Act too.
Okay, great. Gailey, did you see the couple of updates? Did you have anything else you wanted to share?
That was it.
I guess, can I ask just one follow-on? Is there a projection on how much of a reduction this program there'll be a reduction of intake, right? At least, and this is Oregon wide, right?
Yeah.
So in theory, I don't know, does anybody know? Is it like a 10% reduction, 30, 40, 50%? Like, that's a lot of things. A lot of items, a lot of common
Yeah.
everyday.
5% is probably closer, maybe 10, because it's measured by weight and plastics are lightweight. And that's part of what's been added.
The total articles, but by weight it's small, but they are, okay, but by volume, it might be bigger than 5%.
Right,
I mean, I live in the low rent district of the city and, with people I talk to say, what's this gonna do to my garbage bill? So I think that's one thing where we can clarify as a committee is like, okay, if somebody says, look, Republic raised their prices again, well, let's find out what was behind that price increase, if it does.
it shouldn't be related to this. If the rates go up, they'll have to justify it in other ways, but this isn't one of the ways that I foresee that they'd be able, yeah.
Bailey, is there like a recycling advisory committee? I mean, similar to this group here?
There's one for the state.
Benton County.
For Benton County, there's not, I mean, this is the only solid waste group happening right now.
Okay,
But the solid waste advisory, committee is probably gonna start up again in the fall.
okay.
That's my guess.
So we can, this is of interest to us, but nothing actionable. for us.
Right, right, yeah.
I could just mention that NRAC, the Environmental Natural Resources Committee, has interest in the recycling in any fashion, and so this could be referred to them. Can you guys hear me?
Yeah.
Yes.
Yeah. Yeah, no, I think,
They have asked what they can do to help in whatever fashion. So this is, recycling is something that they have a strong interest in.
Well, let's ask them.
well, Charlie's on, you're on NMF, right?
Yeah.
Yeah. Do you wanna float it with them or just make them put this on their radar?
I will put it on the radar. It was part of the questions. You might remember, Bailey, I sent you a bunch of little questions from NRAC and they said, what can we do to help in any fashion? And this is one of the things that we can do to help. So we'll put it on the radar for sure.
Sounds great. All right, any other expansion proposal related questions? Okay, so moving on, we have slated reviewing the last meeting's minutes and their action items. Did anyone have any notes on the minutes themselves? They're quite short.
They look good to me.
Really good to me.
Paper minutes. Looking through the action items, oh, Bailey just left. So we'll go through the subcommittees later in the meeting. Does anyone remember what the landfill map with dates was? It's one of the action items on the last meeting's
Oh,
minutes. Staff just sent landfill map with dates.
oh, yeah. Did I not do that? It was a map of the landfill and it had like the year that each cell was
Yeah.
constructed, I think.
That would be good.
Yes.
Can I add to that? Cause we were, since, at the groundwater committee. With my aging eyes, I'm looking at the maps that are in the reports. Is it possible to get a larger format
Yeah.
map? I mean, I'd like, back when I was working, I usually had a map on this, on my wall, and I could refer to where's well 3B and 4A, blah, 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 blah. Is that possible? I don't know.
I'm sure it is. I know there's one at Public Works. So
There's
you,
one out at the landfill office, a real nice C-size sheet, and boy, that'd be nice to have.
like a bigger than
Yeah,
11 by
a cheat
17.
sheet. Yeah,
Okay.
that would be great.
And is there a particular version of it that you're looking for? Like that shows the expansion or?
No, I would
Like
focus,
the ones in the 24 report.
yeah, the one in the 24 report, even the one from Tuppen in the 23 report. But it's
Okay.
just in what I'm reviewing, and I don't have access to all my good work technology stuff, because I'm retired, so I'm looking at my home screen and crappy printer and all that.
Was it the environmental report?
Yeah,
The big one?
annual report, site map showing monitoring well locations in a large format.
Okay.
That's
Probably in the first section.
in color, that would be awesome.
Ooh, color. Ooh.
I'm sorry to be incompetent, but I just don't have it.
No.
Well, I was gonna say that I look on as a PDF, and you can at least zoom in, you only see this little bit.
I know, I can zoom in and I can, you know, mess around with it on my screens and I'm doing, but it'd be nice to have a map.
Great.
Thank you.
Yeah.
All right, will someone move to accept these minutes?
And
Second.
I'll second.
Thanks. All those in favor of approving the minutes? Right, all right, so the next item on the agenda and the next one before the break is a presentation from Jennifer on PFAS and health related property use. How would you, what would work best for you? Do you want to secure?
We're,
Is it feed up and?
let me pull that up right now.
Painting the slides.
And I think, forget how we, do you have a rough time? For,
I think I tried to cut it down a bit.
just want to make sure we have enough time for questions and stuff.
Take a quick look at the numbers, guys. But that's misleading because there's some animations. So I think about 2 minutes, but we can also just move through some things if people aren't interested. Or if people, I don't know, if people wanna ask questions afterwards, interrupt, otherwise, God knows how long it would take.
I think questions during makes a lot of sense. Yeah,
We can try.
Just our group here and Charlie, I think that's it.
Yeah. Charlie, can you see the screen?
Not yet.
I'm just looking in the agenda packet. I cannot see the screen.
Okay.
There.
I think it's the same thing that's in the agenda packet, but maybe Bailey can find a way to share.
Oh, there it is.
Sidebar and sidebar, it's hard to see stuff.
Here.
Woo. All right, thanks for
Print it
that
up? Good.
monster and winning. Let's see, so. All right, well, if anybody saw the Clean Water Symposium at OSU, it was recorded, it's the same thing, so my apologies, you can go take a nice break. But I tried to trim it down for you all. So it is about PFAS, it's actual research we've done. And then throwing out some other literature in there, because we're not alone in this, it's a worldwide effort, as you might suspect. So people probably know the acronym by now, we're stuck with this thing because it's actually helpful. Per and polyfluoroalkyl substances, big old mouthful, we say PFAS, we see here all kinds of stuff, PFAS, PFAS. PFAS is actually plural, it's many, many, many chemicals, many, many classes. It's been in the press, we all know about that. It's actually, believe it or not, even though I've been working on this 30 years, it is now a household word. And a lot of action in Australia, so I truly mean international. So I don't know if you have seen, I mean, we've had, books, movies, media, so a lot, kind of opened up the case on West Virginia, Parkersburg, Ohio with DuPont. Their Dark Waters was then a movie made on that book. In terms of toxicology, again, just real short here, we have Jamie DeWitt, we recruited her from East Carolina State, and she uses this slide when talking to broad audiences. I'm not a toxicologist, so what it does is it talks about the kinds of impacts, so we don't really rely on animal studies anymore. Initially, it was like rat studies, but now there's been enough humans exposed worldwide that now there are inferences to various diseases based on these large populations. So I'm not gonna read the list, some are stronger correlations than others. I think some of the earlier ones were the immune system, there was a inverse relationship with PFAS exposure and your immune response to immunizations. So quite a few outcomes, again, you can see dark or solid blue lines are high certainty, dashed lines, lower certainty. So you can kind of see they're not all equal, different receptors, different pathways. It actually was overlooked for a long time because people are like, there isn't an endpoint, but there are a lot of outcomes, but it's hard to identify an endpoint. She does a lot of, if you want to hear a thing on tox, she is a world expert on that, has done a lot of talks to even Congress. So one of the things to know is the reason there are impacts like this is some of the PFAS have very long half-lives in the human body. So in the case of PFAS, let's see, do I have them listed? It can range up to like 8 years, 5 to 8 years. So it's in the body for a long time. And the part of the reason is they bind to our protein. So unlike your contaminants, which, you know, Dave, maybe you worked on PCBs or dioxin in the past, maybe somebody else has. Those are contaminants you find in your fats. These are actually found in our blood-rich tissues. So everyone in this room has them in your blood, and particularly things like liver, kidney, and that's true also for fish and as well as gonads. And so tumors in rodents and in fish, but again, we also now have a lot of human studies. So question is what makes these things so special? They just don't follow the book when it comes to other classical organic contaminants, many of which of course will also be in landfill leachates and air. Let's see, whoops, what makes it PFAS so special? Okay, so what is the anatomy of a PFAS? Well, we have to deal with this nomenclature thing. So here's a cartoon. So this is a chemical cartoon. Every one of those is carbon. You see that in this case, R means something else. And there's a lot, that's what makes them all different. They're different R's. But this backbone where every single carbon has a fluorine, that's what makes these special. So for those of you who taught chemistry or close enough to it, the electrons are super evenly shared. There's not like little microdipoles in there that helps molecules, these tails attract to each other. It's really, that's where Teflon gets its properties. There's no real attractive forces between this and anything else, including itself. So that's why you get like a Teflon surface. It's a real nice non-stick oil and water repellent. So that's the fluorinated tail. And when all of those carbons are loaded in fluorine, that's where the word per comes from. Per in chemistry means perfluoride. Every one of those carbons is fully fluorinated, no hydrogen. And it's that particular flavor. Those are the ones that earn the name forever chemical. Because others, when the R gets more interesting, they're not forever because they degrade to the forever ones. So not every PFAS is a forever chemical. So low van der Waals force, so that's why you get water and oil just bouncing off these surfaces because there's no net attractive forces. The R group is where the variety comes from. And so we have many, many PFASs because the R is varying. The chain also varies. You'll hear things about short chain landfill leachates dominate in the short chains. The shorter the chain, the more water soluble, the more readily leached and ends up in leachate. That just, more leachable. And so that R group, here's our buddy PFAS. It's a sulfonic acid group, sulfur, 3 oxygens, one's ionizable for those of you who care. And we give it the name PFAS, perfluorooctane sulfonate. What I do say about sulfonates is they are very ionizable. So if somebody's like sulfonic acids don't exist in nature. That proton is never there. It's anionic. So now you got a really schizophrenic molecule. One end that is hates oil and water, and you got a very water-loving end. So they are surfactants. So it's a surface active agent. PFAS is a classic one. But I tell my students that when you see a sulfonic acid on any molecule, like one of the blue food dyes, you put in cupcakes and icing and whatnot and drink it, you just pee that right out. That is not a PFAS. It is a highly sulfonated blue molecule because the water solubility is so high. So I say it's like putting roller skates on a molecule. It's very, very mobile. Things that would be immobile without that head group, that molecule would be in the atmosphere. But it keeps it tethered to earth and to water because of that head group. Polyfluorinated. Okay, there's that thing you just saw. Every carbon has fluorine on it. It's got some R group on there. But there are many now that are polyfluorinated. And the point is, this was a way to get around patents. So the chemical industry is like, okay, we can't make that because somebody owns the patent. 3M owns the patent. We're going to make this thing that looks just enough different we can dodge around patents. This is where all the telomere chemistry comes in. This is where DuPont's chemistry comes in. And so and if you have an analytical instrument, it's a big deal. Those are very different molecules. Our instruments can totally tell the difference between this kind of molecule and that molecule. The per and polyfluoroalkyl substances, these are the poly guys, and those are the per guys. These things degrade, those don't. So that name, the nomenclature kind of sorts that out. So very similar function, they got around patents, but by having that spot, it is a weak spot. By putting those bugs, a microorganism, your run-of-the-mill bug in landfill leachate wastewater treatment plant knows what to do with hydrocarbons, so carbon hydrogen. They know how to do business there. What they don't know how to do and they can't get any energy from is breaking the carbon fluorine bonds. So polyfluorinates have that weak spot, and that's where you can see things like telomer sulfonate, which looks a lot like PFAS, except those hydrogens that's biodegradable, PFAS is not. It'll degrade something that doesn't degrade any further. That's why we don't call every molecule a forever chemical.
So, but they just agreed the part that's the weak spot, right?
Right, they'll chew on that, basically, they turn this into a carboxylic acid, then it stops. And you end up with dead end products, because the bug can chew off, not microbiologist, you can tell, chews off the carbon hydrogen, and then it stops, because it's like, can't get any carbon energy. That bond, very short, very strong, can't make a living, can't make energy off of, degrading that chain.
Is that a reductive process? I'm asking because of reductive coordination,
People study
stuff I used to do. Yeah.
reductive processes.
Yeah.
We're not, they're right now, even though we've been looking at it for a long time, not clear,
Okay.
but there are major, like, reductive processes. I know some people have engineered some processes that have a reductive component to try to do oxidation and reduction,
Yeah.
to try to chew away at these things. And then if you slip in an oxygen inside that chain, and something like this, it turns out that turns into Gen X, and you might have seen that in the news, because at the very same time, West Virginia, Parkersburg, Ohio was a thing in DuPont, lawsuits and groundwater, massive contamination, very large, 60,000 people exposed. Down in North Carolina, who would have thunk it, but Gen X was discovered recently, but the production was about the same time. And so Gen X, if you are, we have several, Jamie DeWitt's from North Carolina, I have a student from North Carolina who drunk Gen X contaminated water their entire lives. And Gen X is also very stable. For those of you who know chemistry, ethers, they're not terribly reactive. So Gen X was a alternative, but also been in the market a long time. So what more do we need to know? Some of those R groups, so I showed you sulfonate, which is anion, it's not volatile, very water soluble. But some are neutral. And that, for example, when you have an alcohol, this is the major, or one of the major components in landfill gas. And stop. This is the number one right there. Because that's an alcohol, all of a sudden this molecule is volatile. That's why you see it in landfill gas, and you can see it in air down gradients. We call that an FTO, fluorotelomere alcohol. It's got that telomere, that signal that we've got that linkage that is potentially degradable. So an FTO has a very high vapor pressure, they're volatile, and again, number one in landfill gas. And then we get some really odd, I call them wacky groups. This is an AFFF, so aqueous film forming foam, put it on burning field fire, think PDX. Next time you take off or land in PDX, you see that burned out hole, that's where they practiced AFFF. Here in town, I suspect, they used AFFF at that fire training area, that's my guess. A lot of municipalities did. These kinds of molecules were in there that help the foaming. Not that much is known about that, but boy, look at, there's that fluorinated backbone. This tells me 3M made it. There's some really odd chemistries in there. Basically, our lab is one of the few in the world that actually measures these. Why do we care how they're made? Because these are forensics clues about what to expect. 3M used a process called electrofluorination chemistry. They brought a hydrocarbon feedstock from somewhere, North Slope, some oil supply. Hydrocarbons are intrinsically biodegradable. We don't like oil spills where oil comes up to the surface of the Gulf all at once. There's lots and lots of seeps in the Gulf, and the microorganisms at low levels, they know how to do alpha beta oxidation. So hydrocarbon is very biodegradable. But when 3M takes HF, sulfonyl chloride, throws it in the bucket with that hydrocarbon feedstock, and then turns on some juice, meaning electricity, what you have is out comes PFAS out of that process. PFAS is not a pure compound. It was a really messy, dirty chemistry. So it wasn't just PFAS. And HF is a bit of an issue. So there's a lot of those byproducts. These are all forensic evidence now. But when you see PFAS in the United States, you know who made it. And stop. When it comes to fluorotelomers, not so sure. That's the tricky forensics part. And so that is how, PFAS is made. And when we look out in the environment, they're branched and linear. And it turns out branch and linear, they transport slightly differently. The branch is a more compact molecule. David has a slightly smaller retardation factor. And you actually start to see isomer ratios shift during groundwater transport. So now we have a non-biodegradable molecule because we took all those hydrogen carbon bonds, which are edible, and turned them into something that is not. So when we think about forever chemicals, here's our friend PFAS, very mobile molecule, very strong carbon fluorine bonds. And as I've mentioned, they can't really use it for carbon and energy. So it's like putting up a brick wall. and it has a defense against microbial attack, so they cannot derive carbon or energy out of it. It turns out the Stockholm Convention classifies molecules as persistent bioaccumulative toxic, PBT, and PFAS has been determined to be a PBT molecule. And so it's on the list of many other chemicals that are not encouraged, at least in the EU. And there are even arguments now that if a molecule, even if it is not toxic and it's not, let's see, persistent bioaccumulative, if it's not bioaccumulative, not toxic, just persisting alone, and this is the thing with TFA, trifluoroacetic acid, they've been measuring that in atmospheric waters and glaciers for a long time. TFA is a very stable molecule, and the concentrations, when it's like a bathtub filling up, and there's nowhere for the water to go, it's just the concentrations are gonna rise when you have a molecule that has no known biodegradation pathways. The polyfluorinated molecules, as we pointed out, those little blue hydrogens, then you have a carbon, hydrogen, all kinds of fun stuff that bugs know how to deal with in that R group. What we have is part of the molecule is biodegradable, the rest of it not. So we think of that carbon hydrogens as kind of like that crack in the wall. That's how the 1+ where a bug can get a hold of it, and you'll see things poly go to these carboxylates. So when you think of PFOA, this is what PFOA looks like. It's got an anionic carboxylic acid group because the proton is never there, very water soluble. That's C6. It's not PFOA, sorry, that's PFHXA. You see that a lot. So that is a degradation product of the polyfluorinated molecule. So, and now we're back to a forever chemical. So not all of the PFAS are forever chemicals. Come on, let's advance the slides. Uh-oh. All right. Clue, when you're gonna do, we're getting into the forensics business. When you look at these molecules, they're only linear, and they'll only give you linear degradation products. So
Sorry, what does that mean? Linear?
linear means the chain, just as a zigzag, versus if it were branched, one of these CF3 groups could be like here. But you don't see that because the process used to make telmers only gives you a linear chain, whereas 3M is diagnostic, branch, and linear. It's getting a little weedy, but if you're interested in figuring out who done it, which is where the little spyglass comes from, these are important clues.
So how do you break the chain?
A lot of energy. So you're gonna see thermal processes right now. You'll see sequestration. So how do I sequester it into carbon? And then you can burn that carbon. So it's mostly high energy processes. That's why it gets really expensive real fast for these perfluorinated molecules. So yeah, that's why biodegradation basically is out. You can like biodegrade to a point, but then you can maybe drive things to a common base, and then you're gonna have to use a higher energy method. Super fantastic source of information, the ITRC, Interstate Regulatory and Technology Council, actually a lot of voices from a lot of different sectors, like crowdsourcing PFAS information, super graphics, a lot of great information. And what this basically shows is if, let's say you get a whole bunch of diverse PFAS goes out into the world, fire training areas, landfills, wastewater treatment plants, industrial emissions, think semiconductors is a good example. When you have polyfluorinated molecules, a little bit of biodegradation starts to narrow down, takes some of that complexity and makes it less and less complex. So by the time you get down here, you're down to those few species that don't have natural biodegradation pathways. And so when you start thinking about transport, transformation, a recent spill will have more diversity than an old spill. If you're close to a source zone, you're gonna see more PFAS than farther down gradient. And if you've had some sort of remedial source zone treatment, pump and treat, etc., injection of oxygen, anything, you'll start to see it go in this direction. So we end up at the bottom here with products that are more challenging to remove. And the shorter the chain, the harder it is to remove from water. So you think granulated activated carbon, it's a sequestration approach, great for PFAS and PFOA, but by the time you drop that chain length, it's getting hard. You're gonna see those molecules start to bump off in like a gap. You'll actually see like a spike in C4 because it's being kicked off by the more sorbed molecules. So you need kind of like a 1-2 punch. How am I gonna get the hydrophobic ones? And then how am I gonna get those little short chains remember, landfill leachate is a challenge because it's dominated by, it's not entirely, but it's dominated by the short chains. They are the more leachable component. So, I would highly encourage you to look at that. So where are these? So it's kind of like romping through, why do you hear that they're everywhere? If you start with industrial manufacturing, what we know is probably a lot of things, it's so nice in here, from the paints to the upholstery to the carpets. When you're in a high use building and you want it to last a long time, these are terrific additives to your products. That makes that couch, all these things will last a lot longer. So goods and articles in our lives, in our offices, homes, and schools give off vapors, they give off dust. And so that inhalation, take a deep breath, we're probably picking up some aftos if you bought certain brands of paint here in town, study we did. And then, or if you breathe in, you're picking up particulate matter. So those are routes of exposure for low-level background in places, and how humans get some of their exposure. We also know, and we don't really have a lot of manufacturing here in the state of Oregon, but boy, they sure do in other parts of the country. Here, for example, around 3M's manufacturing sites, a lot of wastes were land applied. There were also landfills, especially in the Minnesota area. And even just effluents are going to local wastewater treatment plants, and more on that later. And we know, particularly in our area, our effluent goes to surface waters. In other cases, let's just kind of start with firefighting foam. Again, that happen in lots of different places. Firefighting foam infiltrates into the ground. You've got groundwater transport. You've got impacted farmland, groundwater, and eventually can reach to surface water. And that's a pretty potent, probably the most concentrated, so it's grams per liter in those concentrates. Here, landfill leachate is an important route for disposal of goods. It's going from your home to the landfill. We know that landfills then can export their leachate to the wastewater treatment plant. We also know that biosolids can go back to the leachate, and that was or is true here for Alice. Until it's no longer permitted. And then wastewater treatment plants, as we know, their solids can be then land applied. That's true here in Oregon. That's true. And in some cases in the United States, particularly Maine, we had whole herds of cows graze on that grass and had to destroy the whole herd because the levels were very, very high. That's happened in a number of locations in the country. That's why there's such a focus on biosolids. And of course, that land is used to grow crops. There's plenty of studies now that show how plants take up molecules from the soil environment. They're particularly good at the water soluble ones. So they're more enriched in the short chains over the long chains. And that's how it gets into the new food supply. And then of course, surface water is typically, it's where fish live. It's a drinking water source, gets treated. But again, treatment is challenging. And that's how it informs surface water signatures. And then we know that parent-child, parent-infant, parent-fetus, there is this circulating between cord blood and the breast milk that goes round and round. And I don't remember what those are about, so let's keep moving. So let's move on to ideal landfills. Nice cartoon. This is from Mort Barlatz. Nicely engineered systems, idealized systems, hole in the ground, sophisticated liner system, which we have here in the newer part, and then ultimately covering the vegetation waste. And there's also gas collection and gas wells and monitoring wells. And of course, the groundwater group is thinking and talking about the groundwater wells. Idealized. I say the student of Mort called him the Brad Pitt of landfills, and I'm like, okay, because he really was one of the best landfill engineers in the U.S. in my opinion, with a heavy bent toward the microbiology of what goes on in landfills, sort of anaerobic processes. Real landfills look a little bit different than the highly idealized cartoon. Here is our postdoc at NC State. So he's taking the gas. This is an explosion-proof pump, so that wherever he goes, he doesn't blow himself up with the pump. And he's pulling air through small thermal desorption tubes that came back here to Oregon State to have the PFAS measured. So we actually participated in a national survey with Mort. Mort is the guy with all the connections and has all the professional connections with groups like Republic Services. So he was able to get permission to sample 17 solid waste landfills. This was actually for the leachate. So we ended up with 41 cells, and there's different cells. Every cell has a known open and close. All cells have PFAS, and it's not just C4 and the new ones and C8 and the old ones. C4 has been around a long time. So a lot of cells and really trying to understand high conductivity. That means seawater, for example, is about 55. So some they're not as salty as seawater, but you know, it's a pretty thick, rich medium. It's also very smelly. So high strength, lots of organic matter, and compare that to say wastewater. So it is a much more concentrated, challenging matrix to deal with. And it looks like that. So you get a feel, here's a log of the concentration. So log 2 is 100. And so we get up into log of 4, so that's 10,000. So you've got a real range in concentrations, and all this mumbo jumbo alphabet soup are just different PFASs, different classes. There's quite a bit of a diversity there, and yeah, just a ton of acronyms. And so what we see is a lot of these acronyms undergo degradation, and they will end up with dead end products. Now, this one is not a dead end. It turns out this is pretty diagnostic of landfill. You don't see this many places. The only 2 places you see it is leachates coming off of biosolids and leachates coming out of landfill. So it's a diagnostic indicator. You see that elevated, and there's our friend. That's the polyfluorinated. This is actually an intermediate. This is not a product that we know of. This is an intermediate in the degradation of all those guys, and it's pretty rich in landfill leachate. We discovered early on there's no such thing as a blank. That's also true for wastewater, municipal wastewater. There is no such thing as a blank. They all have background levels of PFAS. Leachate for us gets second prize. The only first prize in terms of environmental media that's more contaminated is AFFF, contaminated groundwater. That's that repeated year after year, month, and sometimes monthly addition. So here we're up in the micrograms per liter range of PFAS. So it's our second prize. We just saw 40 milligrams per liter of a single PFAS at a fire training area. So that's now the number 1 in our lab. And contrast that with wastewater effluent, which is only nanogram per liter, like tens and yeah.
What is AFF?
Aqueous film forming foam, that's a firefighting foam that's very notoriously high.
And then they still use PFAS in the foams?
There are let's see, entities like the airport were required by the FAA to use mil-spec AFFF, and fluorine-free AFFF was only available in the last 2 years. Now, has PDX switched? I don't know. I know it's really hard. There's higher viscosity. It's harder to deliver. You got to retrain different PPE. But it's a different animal, but a lot of people are moving in that direction. Australia has certainly moved in that direction. But what you're stuck with is 30 years of the other stuff. And all of these concentrations are above the proposed EPA MCLs. There are more PFASs than are actually listed. So right now, if you wanted to go out and buy PFAS analysis, you might go and get method 1633 from a laboratory like up in Kelso. So that's what people are using right now for analytical methods. And there's only 40 on there, but they're the ones that are pretty frequently detected. And the short chain PFAS, again, as I mentioned in leachate, are the most abundant. They are the leaching fraction. And yeah, as I mentioned, the 5 to 3 FTCA is diagnostic for landfills. And the thing about landfills is that those systems have very long residence times. And, you know, it's meant to keep those materials in there. So degradation does proceed. And there are estimates that it will take, 40 plus years if you stopped material today, it will continue to leach from articles for up to 40 years. So the punchline is landfills are long-term PFAS sources. And if you can keep it in there, you're doing well. If you have refugee emissions in gas phase or in groundwater, or if you're exporting your leachate, then that's how those materials begin to, again, start circling around in the environment. So where does all that leachate go? In our case, in this town, we know that up until, this December, it comes to our wastewater treatment plant. So kind of coming here toward the end, landfill gas sampling, very specialized going into these systems. You obviously have to have their permission. They are partners in this to go on landfills and to actually sample these gas wells. So you're actually standing on the landfill, you're not downgrading. This is actually being on the landfill. So we picked up 30 sites, annual precipitation from arid to wet. They accept a whole variety of waste from municipal construction, demolition, ash, and then biosolids. We know about that, ash being a big thing. Our sample set was accepting waste from the 50s all the way to present. In the 50s is really and 50s and 60s when the fluorinated chemistry really took off. And we've captured a wide range of waste decompositions. And this is how Mort knows how this, he's looking at cellulose, he's looking at methane, he's actually also looking at methane at the same time. So after you do all that sampling, again, we have different landfill gases running around the bottom. There's what, 30 sites. Now this is nanograms per meter cubed. So let's see, what is that? So that's 20 micrograms per meter cubed. Like if you're benzene or methane, you're like way higher than that. So these are orders of magnitude lower than other major components you would expect in landfill gas. But you can see the concentration is we have the sum of PFAS, and what you can see from this graph when you compare blue and gold, pretty much all the PFAS in this is one thing. It's 6-2 telomer alcohol. It's the dominant one. When you breathe that in, your body will change that into an acid, and you'll either excrete it or you will accumulate it. So, major FTO, yeah, it's volatile and ends up in the atmosphere, and you can detect these down gradient. And they're in gas, they're orders of magnitude above ambient air. But if you were to analyze the air in this room and the air right outside of there, I'll bet you it's higher in this room than it is outdoors, because of the articles are off gassing, like paints. Or anybody do air sampling in their air quality? It's a big number. That's not, if you paint that dries in 3 hours, all that weight that's lost, gotta go somewhere. That's all volatile. It's paint's really interesting. So yeah, FTOs degrade to PFOA. So other folks out there have put together like the big picture. So what's going in? Municipal waste, biosolids, other sources. We have uncontrolled and controlled emissions. So controlled emissions, they actually collect gas, they collect leachate, we know about that, they do that here. But then we have these uncontrolled emissions, which are lower, and they also take the form of gas emissions and also leachate if you have leakage into groundwater. There is flaring, we have flare in town, or at this, it's not entirely well known what the products of incomplete combustion are as they pass through the flares. They weren't necessarily built or optimized. We know that these can undergo combustion, but it really has to be highly optimized combustion for PFAS to degrade. And the estimate is that these leachate and gas emissions, the fugitive emissions, sorry, I have that right? That they're about, the new estimates, they're about equal instead of the dissimilar. These were based on older data and not measurements, but since our new measurements, they've updated the emissions through the gas phase. So what do we have here? It's rough proportionate. So total PFAS entering municipal solid waste in the form of landfills. And again, it's sort of a graphical representation of how much is accumulated, what's emitted by leachate, what goes out as gas. So we did some model landfill reactors with Mort. What does this mean? We have substrates here, papers, textiles. A lot of papers and textiles, there's a coating that's put on. It's called side chain fluoropolymers. It's a single coating rather than incorporated into the material. And what we know is that those materials are designed to be oil and water repellent. And then how do you study what's going to happen to that? Well, you stuff it in these weird bags. It's super stinky room. And this is Mort Bar Labs at NC State. These are model reactors, and then he has the ability, right in here is the solid waste. And then he's doing gas collection, he's doing leachate collection. So we actually helped analyze a lot of those samples, and that's how we began to understand what happens as these materials degrade. Well, we've got natural loss of those unbound residuals, things that are just part of the, synthetic chemistry process. But then as that paper actually degrades, so cellulose degrades, the substrate's actually degrading out from under, at least that's what our hypothesis is, leaving that polymeric coating. The polymer doesn't degrade very fast at all. It's like hundreds of years estimate, the polymer itself. So we don't think about exposure to polymers unless you had inhalation. So we've done some reactor studies. This is a cartoon of our wastewater treatment plant back in 2008. It's probably been modified since then. Anybody been there? Right? It's an interesting place. Everybody should go. Everybody should know where your bodily emissions go. So raw effluent, then we've got sludge is sort of separated off. The new name for sludge is biosolids. So this is how these solids are dropping, they're thickening, they're anaerobically digested, they store in the lagoon, and then out to landfills or land that will accept them. And then the liquid will go through a trickling filter activated sludge, it's an aerobic pathway. So anything that's aerobically degraded can happen up in this particular area. And then effluent, in our case, goes to the wastewater, goes to the Willamette. So we had trucks coming into our wastewater treatment plant. I don't know the number daily. I'm sure somebody else knows that a little bit better. Kind of trickle it in, so it's not all one slug at once. And then we have the emissions in the Willamette and also land application. So this is data from our wastewater treatment plant from 2008. So this is milligrams per day of PFOS. Yes, so the units are milligrams per day. So we measure about 420 milligrams a day, taking samples over time. The black is the solids bound, the blue is the aqueous bound. And so you can see we do have a fraction that comes down to the thickener. And again, you see the bar actually getting larger. There's some residence times here. It's grab sampling. It's not perfect. But you see a biosolids about 230 milligrams per day going out, about half of what, is going in here. You can see as it propagates through the system, you get 600 plus 200, about 800 versus 400. So what you have is, and this is, thank God, been repeated endlessly around the world. People see this mass balance in the sense that we see more coming out than going in. Now, how is that possible? That could be degradation of other materials that degrade to PFOS. Also, there is a periodicity in here of sampling. So it's pretty interesting. So what goes in actually does come out. It's just where is it going? It's going in part to the Willamette and part to the biosolids, because there isn't degradation per se of something like PFOS. So when it comes to PFOS, what goes in goes out.
Are there wastewater treatment plants that do actually filter out these things, or is it just?
If they are conventional and not optimized, I mean, that's the problem. And everybody's trying to say, well, how are we going to change these plants to, now if you have RO, I think it can do a good job. Does it do a good job in the short chains? I don't think as well. I think RO and other high-end, more expensive, more energy-intensive processes are being used. I think you'll see that in industry. And I'm not a wastewater treatment specialist, so I don't really know what the answer is. I know that treatment plants around the world share this problem. Do they have the resources to upgrade? It is a matter of money to really put some sophisticated treatment, at least on the aqueous phase. All right, keep going. Come on. Come on. All right. Heard that? You've heard that. It's fairly ineffective for removing PFAS. So remember the flyer? The stop the landfill expansion on the back, it says go straight to the Willamette. It doesn't go straight to the Willamette. It goes straight through the wastewater treatment plant to the Willamette and to the biosolids. So there is accuracy to that statement, which is unfortunate. So the problem is that the volume coming in is relatively small, and it gets relatively large because of the dilution. So you're actually taking a concentrated problem rather than, and that's what you see Mort Barlatz and other wastewater landfill engineers suggest. And I think that's what you're seeing Republic doing, is looking at what treatment can we apply at the site of generation, so that they're not having to come up with a system that will handle really large volumes. So treat it when it's the smallest volume, most concentrated possible. That's where you see things like foam fractionation. So where it's high enough, you can actually get a froth going in a foam, and that actually helps concentrate, and they pull off that foam, and that foam collapses and you get a concentration process. So I think you'll probably see I know they've spent some money on investing. Also, people around the world have really looked at foam fractionation as a way to treat landfill leachate, or to help, that distribution of PFAS, because foam fractionation is it's an old, kind of like low-tech way to do stuff. So here we are, the end. So they are associated with lots of things. I think you're seeing a lot of pressure to get them out of unnecessary articles. Our use in their discharge, when we did atmospheric sampling on Mary's Peak, we were looking at air mass. It's interesting, NOAA, when they were funded, back trajectory, you can tell where an air mass came from. You can tell where the air mass today came from by looking 4 days ago. It could be either Asia, or it can be coming from the south. And it turns out the concentrations at Mary's Peak in the atmosphere are greatest when the winds come from the south. because the Bay Area has a lot of people and a lot of consumers and a lot of articles. And so our own neighbors to the south gave us the highest air concentrations compared to, you can imagine that, much higher dilution rates coming in over the Pacific. So we are all responsible for what's being emitted, and landfills indeed are one of the second most concentrated sources of the environment. And it's the fugitive emissions that we have the least control over, and that is it. And our funding comes from this agency, which is still alive as far as we know. Thank you, Jennifer.
Thank you very much.
So, one question, you said, ideal combustion, so. Yeah, for removing PFAS, what would you by ideal? Cause you look at some of flare-offs and some, don't have quite the right air fuel mixture, some have a nice pretty blue flame depending on, they probably have variation in their concentration, why they can't optimize or is it a temperature thing?
I think it's a temperature thing. And so you really need those much higher temperatures. So if you have a non-ideal, like a flare isn't necessarily a highly controlled, like for example, the Umatilla Army Weapons Depot, I bet you that was a very highly controlled.
Right.
So that's very expensive, kind of system. So I think a flare is not optimized in terms
Right.
of thermal profiles and feedstocks. And so there's a whole bunch of money going into understanding incineration and combustion. But again, very energy intensive, expensive process.
Oh, and if you flare it, you still have fluorine going somewhere.
Yeah, the question is what form? What we see, because we're doing thermal stuff now, if you burn up munitions, there's a concern that there is fluoropolymers in weapons. And so during the Biden administration, had a big concern about burning weapons because of Son Biden.
Yeah.
And so we have a project from this group to understand what happens, what does fluoropolymers make? They make C2F4. That's the predominant thermal degradation product at 800 degrees C and higher. And so that is, I think that's a greenhouse gas, although my knowledge is really.
Yeah, I think that's part of the problem. If you get rid of the PFAS and you're making this fluorinated compound, it's better if you pick something that's not going to become its own problem.
That is one of many challenges when it comes to the treatment of these things.
So, and then you also mentioned about the flyer saying the leachate goes in the Willamette River, I think.
Through,
Right,
after
well,
it's transited through the.
But I think the speak and the outrage that came from some is that are quite misleading, saying, well, are they just dumping?
That is misleading, that's the wrong word to use, yes,
Right.
it's diluted into the land.
A couple of landfills in the area have tried doing reverse osmosis to treat their.
Including ours.
And right,
They shut it down. When I first came to OSU 30 years ago, I got a tour. They're like, oh, it's never really worked. So I think it got shut off like
was that,
30 years ago.
is that a technology though that would be able to deal with PFAS?
RO does great with, I think, more polished. I think you need more steps in front of it to make RO really, it's,
Yeah.
that membrane gets fouled really
It
easily.
did foul pretty well, the material that's in the landfill, you have to have a pretty clear compound. It's used for desalinization, things like that, but there you end up with materials with a lot smaller molecules. And so that it was closed primarily because it would fail quickly during
Yeah.
operation.
There was no pre-treatment in front of it, so it wasn't viable. Good idea, just wasn't a great, what you see a lot of is the idea of trains. That you'll have a treatment train and you're stacking, again, maybe oxidative, reductive, RO, polishing, ion exchange, just they're trying to come up with everything they can. Very difficult.
Hey, Jennifer, on a practical level, I was looking at that proposed MCL. First of all, can labs get a standard commercial lab get down to that?
They can now.
That level?
Yeah,
Standard
it's,
commer-
that method
nanogram?
1633 can get to sub 1 nanogram per
method
liter
is
levels.
that?
Method 1633, that's sort of the going current modern method. You'll hear others thrown around. 533.
And for sampling and monitoring well, for example, because
Yep.
somebody might
Yep.
suggest that here. Is
They
that
can
even
do
a
that.
feasible thing
It is,
for
yep,
a standard?
yep, there's some really great labs.
Okay.
Lot of there's so much monitoring going now, that market is just really grown, so there's so many labs.
Yeah, it was just peaking when I retired. It was just starting, emerging contaminant wasn't, and then I said, see ya.
Yeah, I don't really go for those levels, I'm not a drinking water low end, I go for the highly contaminated
Sure.
things, so I don't have to
But-
kind of stress. Yes,
Freely
absolutely,
available.
yeah. Well, Sergeant Murmur, who's now in our unit, he's got there's an Oregon House bill on biosolids that passed. So he's got an instrument that, mine's kind of built for discovery, his is really built for low levels, to be able to hit 1 nanogram.
Yeah, we used to send stuff to OSU every now and then, or other,
Not many
university labs, but.
We're not really I mean, we're not designed to kind of compete with that open market, so all that monitoring goes to ALS Global and Vista and
Yeah, the big
Axis,
guys. Yeah.
and they're just labs, Eurofins making huge bank, but there's
Okay.
also fierce competition
Okay,
kind of
thanks, that's
driving the
good to
cost
know.
down.
That's all.
Yeah, it's,
All right.
you probably pay $300 a sample and you're gonna get really good data.
Okay.
It's not terrible.
So, I had a question, if you had zero rain here, you'd have less leachate, right?
I
Is it-
believe
is-
so.
Is it, I don't know, is it significant? I mean, if you have
Well, I
really big cover, that you wouldn't get the water in. Was it
So
really-
our representative made no names person, you want to know a PFAS name, I can tell you.
Yeah.
But, his point was a unit of garbage has the potential to make leachate.
Right.
It's just, so like here, we're gonna have more leachate because of our rain. You put in a dryer, which was the argument, right? That if we trained it out to Arlington, you'd get less rain. It's not that, there's still the potential to release it over it's over what period of time this gets released. So here it's faster because of our, rain is higher. I've seen comments about the extent to which this is covered or not covered. Of course, if you cover it, you're gonna reduce that. And I don't know the nuances of our covering process here.
So yeah, my question was on, just having a leachate pond evaporate, which is what happens over in the east of Oregon, right? Isn't that how they
Yeah,
handle it?
you would concentrate. Now your volatiles are gonna go, but everything else is just gonna get more and more concentrated. Yeah, because you can bank on that process. Air stripping, so the process of bubbling air through water to strip out the volatiles, that was a really popular thing to do for volatile contaminants like benzene, toluene, ethylbenzene, TCEs, when you had the dry cleaners. But they're now stories. So when people were doing that, they didn't know about PFAS. And so when you bubble an airstrip, you're like, yeah, I'm cleaning out my air contaminants. But what happens is that water, they just pour it back on the ground. And so wherever there were PFAS co-occurring, yep, they were stripping the volatiles out, but the PFAS was just being discharged because the water was clean. And there are now several reports where that happened, and now they have a big, spread the PFAS even farther, not knowing it, because we really didn't have the implementation until about 25 years ago. And so up through your entire career and a big chunk of mine, this wasn't a thing because we couldn't see them. And then once we had a breakthrough in technology of instrumentation, that's when we were able to see them. That's why it went for so long.
Have you heard of any class action lawsuits against Dow?
Many, probably too many to count. There's even, like right now, airports as an entity have like air services. You'll have multiple entities on an airport. The airport has a problem, but they're like, entity A did this and B did that. And so you now have multiple entities on, and so now they're looking at each other. You've got poor, local fire stations going, I've had people call me, could our fire station? This was up, Issaquah, Washington. There was a hit up there. And the fire station from that area called me and said, we can't be the source of this, can we? I'm like, well, have you trained with AFFF at your station? Yes, but I'm like, well, yes, you can. And so even the firefighters really didn't know.
So, as far as, all these variations, what happens during incineration? So.
Good question. There is some funding of incineration. The ones people tend to focus on are the harder nuts to crack, which are PFAS and what you can crack that nut, you can crack almost all the other.
So I
nuts.
mean, so these garbage incinerators have been studies of the, at their stack emissions, what's left over. Anywhere?
Well, for those of you who've been, the funding for these kinds of things has been very, very patchy. And I suspect at the moment it will become more patchier. So it's only in, I'd say the last, less than 10 years, people really looked at incineration, unfortunately, as like, a very effective but very costly approach. But in terms,
Costly approach, being they do power generation.
But, well, just to run the incinerator, just to treat the waste, it costs a lot of
Oh,
energy.
so you're talking, but what about the versus a solid waste incinerators and?
Oh, that's a good idea. So Barry Dellinger, I don't know if anybody knew who Barry, he was a very, very good, incinerator engineer, and unfortunately he died, and I don't know who's sort of taken that over. I suspect it's not a very well funded, although I think CERDUP is now funding more and more on this consideration, so not maybe from a public waste point of view, but from an AFFF military.
Sure, well, I mean, so we know, we talked, so if you just talk PFAS, okay, they exist here in the landfill and leachate, but what if? Now, do they exist once you burn the garbage? What's the concentration? Do we break that chain? Short
It's
chains
gonna
and
come
all?
down to how that incineration is operated. Is it optimized for PFAS destruction, or is it operating in a
Well, right,
suboptimal?
naturally, is it better, or is it equal to, is it equal as far as generation unless you opt, the more?
I think you're into an area where I don't think people have very many answers. We do know that incineration can generate HF, and that is definitely, that gets into your bones, and that's very, very.
Right, but then we have technology too, I mean, that we were to use HF, and we have ways to capture and protect and all that.
Yeah, but now we have to think about that in these
Right.
bigger, municipal or has waste kind of systems.
We're
And I'm not an expert in that area.
Until up there, what there's, they use plasma gasification, but that unit was, but then the military used it too. When they were coming out with it, it gets up to about 5,000 to 7,000 degrees. And then comes out in a rock formation there too, but one California city put it in, but the cost is about 65 million. And they can only get about 100 tons through it.
Well, when I travel to countries that don't have, take Singapore, for example, they don't have the waste for landfills, they incinerate, power generate, they air condition that place, so it's like, well, let's generate power out of our solid waste.
But it's emissions, that if they, you gotta have, if you got the emissions, you gotta capture the emissions, so you get back to the point, whatever you do with emissions. So then you gotta have, that's up there at the burner up there in Brooks.
I thought that got shut down.
Well, it got shut down, but what they did, we were looking at is taking the stream of the sands and stuff that had contamination, run it through plasma gasification, and then clean it, reduce it that way. But that was another $65 million.
All right, I'm gonna stop this here so we can have a break. But thanks again, Jennifer, that was really great. Let's reconvene at, make it 7:22. All right, so next up on the agenda is updates from the subcommittees. I think each subcommittee was able to meet in our off month last month. I think everyone prepared at least something. So why don't we get things started with odors and methane, which is Jennifer and David Huffman.
Sure, thanks.
And I wasn't able to print it. The
But you
printer
got it
was-
up on the screen.
So I've got it up
And
here.
Charlie,
That-
here also.
I think so. Charlie, can you see the document that's up?
No, I cannot. I actually was just following the last thing along with Jennifer, like with the slides that are in the agenda thing, because it never went forward. It just continued at the first part of the.
Hmm.
So I don't know.
Well, this one is in the meeting packet, Charlie.
I'm happy to follow that.
Yeah, starting on page 36.
I didn't see it in the meeting packet, but I looked at the phones, I got that mismemory. So, shall I talk or do you?
Sure, please. Oh, I'm sorry. This is like a recap of what you guys did, which is not the same thing. as
Yeah,
this.
that's not
Okay,
this one,
yeah, all right.
which I
I submitted on the 26th of June. Anyhow, so basically, I'm gonna be kind of short here. We discussed odors and methane emissions. And we had a few, see where it says after discussing odors and methane emissions?
Yeah.
We had a few conclusions, and then we're gonna ask for the committee's support and us to continue. First of all, we think that the human reporting of odors, which is the current process at the landfill, is inadequate. And because it doesn't really monitor the emissions, people may or may not bring in a message, they may not fill out a form. Whereas there is equipment that can do this. I mean, it's well known that you can measure aerosols and air and atmospheres. So why are we not doing it? Because one of the arguments I've heard 2 or 3 times is that, first of all, there weren't any reports of any issues, therefore they have nothing to go on. Another one that I've heard, and I think we mentioned, was we hear, well, this odor is not coming from the landfill, it's coming from somewhere else. Okay, now we can pin that down if we had tooling that actually measured the odors at the landfill site and around it. We would know whether the odor was coming to the site or being emitted from the site. So that would get rid of this discussion about whether or not there is an odor. Okay, and the second thing that we said, that even if the human reporting is the source of notification, it is inadequate to determination of the source or the concentration or the composition. You know, you can smell, hey, it smells like perfume. Okay, but you don't know whether that's like ethyl acetate or, you know, some fragrance from somebody's perfume. It could be anything. You don't have that detective scheme, but it's analytical techniques can do that. So why are we not using them? Seems insane. So I believe, and I think you all share it, that we owe it to the residents of our county to ensure that emissions from the landfill and the PRC, which is part of our jurisdiction, are at levels that do not endanger the well-being of our inhabitants. Okay, and that's why we should be monitoring. Now, I don't believe this is necessarily a requirement for the for Republic or the people that work at this facility. I think it's more because of the fact that we as a county have accepted this system, that we need to then make sure that it's staying within what we expect to be its requirements. So that was, so the fund, that's why it's the funding for such monitoring should be borne by the sources of emissions, which is the regional users and operational landfill. That's one option, but then again, maybe the funding for this should be from our county, because we are the ones that are enabling this. I can move down to the rest of it, I can't quite see.
Actually, David, could I ask a
Sure,
backup for a second? Like, what's the core problem that's not being addressed right now?
the core problem is that we have odors that are emitted. And those odors tell us that there's something being emitted from the landfill, but we don't know what they are. Okay, but another issue is that the odors are emitted, but we do not know if they actually are from the landfill or the PRC. They could be from some other source. And I've been in 3 or 4 meetings of this committee when odors have been brought up, and the argument has been, well, we don't think it's from the landfill. Okay, so why should we worry about it? Okay, so I see no reason that we need to even have that discussion. The recommendation is that we develop a means to identify odors and determine what they are. And that enables us to go further.
And these are these odors are like, every once in a while when Corvallis has a smell.
Yes, for example.
You're talking about. Okay.
Or anywhere else in the town.
Okay.
Yes, mainly it's a result of weather conditions that kind of lock in smells and this, you know, the exact problem thing that Mr. Hackelman here said. You gotta, what's the source? As you
Yeah.
know, I've had the, you know, fertilizer on the adjoining field. Neighbors say, gosh, I can smell landfill today, oh, that's Gilmore's fertilizer.
Yeah. So, and the composition of the emissions that you can smell are one thing. They may or may not be really dangerous to your health, other than making you not like the smell of like dilute hydrogen sulfide, you know, rotten eggs or something. But there could be other things being emitted at the same time, for example, PFAS aerosols.
Benzene.
Is this something
We can't
that's,
smell some of these things.
maybe you, excuse me, maybe, seven state, is this something that's being done at other municipal landfills in Oregon?
I doubt it,
Yeah,
because it's not required.
okay, that's where I was headed with this, so why would the Republic do this?
I'm not asking the Republic to do it.
Okay, all right.
I'm thinking that we owe it to our community to know what we are enabling to be emitted.
Is it expensive? We know that? I mean, is
That's,
this
we
like
wanna
a-
go
it's like
forward with finding that kind of
$100,000
stuff
or
out.
10,000.
We haven't got that far.
Okay,
I mean, it would cost something, just like any analysis, any. The technology exists, just like the methane, right? There,
Yeah.
that's one molecule, CO2 is one molecule, whereas if you took a more holistic approach. And you may not know what causes the odor to me is just a proxy for a bouquet of things you can and cannot smell. Things that would be very high concentration to be very low concentration. You smell anything, we're not known to have acute smell abilities. So there are likely other components like benzene, the methane, very high, but we're not detecting, we're detecting something. So it's a poor proxy
Yeah.
for an
If-
analytical method.
is there any connection to their, or I'm trying to think about
Sure.
how to provide some leverage on, is there any connection to their Title V permit?
Well, we'd like to investigate that.
Yeah,
But the other thing I was gonna mention is, I'll give you an example of a highly toxic substance that has no odor, and that's carbon monoxide. Okay, and in an area where you have a pit, a normal mine, you know, if you have a mine where you're mining coal or something, you will have carbon monoxide detectors to ensure that the people that walk down there aren't gonna die.
I want in my basement.
Okay, yeah, okay, but we don't even have that in our system.
Okay.
And that's a simple example of something you cannot smell that is an issue, because it's a heavy gas, for example. So I think we should do something, and that's kind of what we outlined in our phases here, which, thank you for putting that up, is we had to figure out what we might have from some sampling. And then from there, create what we call fingerprint spectra of what's being emitted from the PRC and from the landfill. So we know what they are. And then from there, decide, after we analyze what this is, whether or not we need to monitor. Okay, and if we do, that would be based upon the concentration and whether or not it is of acute toxicity or something like that. That we would then explore and identify methods to monitor. That's what we'd like to proceed.
One of the conditions of approval was some monitoring odor and actually having a third party come in.
I didn't hear your first part.
It was a condition of approval for the landfill expansion was odor monitoring. I think it was OP7 and
Yeah.
their thing. And they actually were gonna have a third party. And they had a consultant talking about these units that they were gonna walk around with. But I'm not sure if it was gonna get to the detail of the actual
Yeah, they're-
composition.
Yeah, odors, well, there's a tool that people use for odor monitoring. And that device basically uses the human nose.
Yeah, it's a big long deal he was talking
And you
about.
vary the concentrations.
Yeah,
Okay, and that lets you know that yes, there's an odor and it's at this level. It doesn't really tell you what the odor is.
right.
Okay, and we're looking at more finding out what is being emitted. And then deciding whether it matters. Okay, you know, if it's merely an odor that's noxious and annoying, that's one thing. If it's an odor that is gonna do something to physiology, that's another thing. And
So Coffee Bean hasn't done any of these kind of like emissions after I.
I have not seen any in the reports that I've read, and I've read them all the way back to 1990 or so. There may be some, but I haven't seen it, and I don't see it being reported. I know it's not being reported.
I mean, I wonder if that might be a very kind of like low like an easy place to start would just be to ask for public what they could share. And just see whether they have any data available.
I think if they're not required to do something, they don't do it.
Correct.
Okay, and they're not required to do this.
Yeah, and I mean, but to Dave's
we can
point,
still
like,
ask.
also all the Title V stuff, right, which is.
Well, since I've not looked at the Title V stuff at all, I don't know what it says.
If we were to do it, would we have to be on their property?
No, we could be, but if they give us permission, but
Right.
you can do it for my property easily. Cause I'm joining. You know, and there could be the argument that, well, it's on my property, but it's not on the landfill. Okay, even though we share a fence. Okay, so I don't think that would hold any substance, but the point is that ideally we would go to the landfill and take samples. And then analyze those samples of the emissions, the gases. Well, that would be the easiest. And we do the same at the PRC. Then we'd have these fingerprint spectra of what the heck's coming out at that time. And they more or less probably stay about the same. There might be variations in concentrations over the years, and we might need to do it when there's been a heavy rainfall and when there hasn't, but we can do that sampling.
You're talking about air sample.
Yeah,
Yeah.
Do you think we could request money from the county if we wanted to undergo some kind of project like this? Sure, we could. request whatever we want.
You request it.
I mean, like, you know, just to, for like a small kit or something like that, was to pursue something like this.
Yeah, I don't have any context for, you know, what the cost is.
well, I think we can make the request, sure.
Yeah, I mean,
Whether they would do it or not.
I think like,
Yeah,
yeah,
it's a landfill research fund, it's called the ERE, but it's hit or miss whether you can get funded. It's usually for operations optimization, not necessarily not.
So just on another subject, a few years back when we had SWAC, the county gave us some grant money, SWAC, to do some programs out in community reductions. So what I'm saying is that, if we have a good plan, and it is, it is amenable, I think we could apply for the county to say, just want to do an independent study to DSAC, and then have the parameters, the cost, and then what the end product is. I think it's doable.
yeah.
Something I've been wondering is Senate Bill 726 passed, which will require monitoring of the air emissions around Coffin Butte. And it's the focus of that, I think, is more on methane, but I wonder if there might be an opportunity there to get equipment that can look at not only methane, but you know.
I think the bill is saying that they must utilize advanced methods or something like that.
It's pretty. Yeah, it doesn't say in detail. It tells you, yeah, what's an advance of it.
Yeah, methane is kind of like challenging to do because it's hard to absorb. So the odor causing compounds, methane doesn't have no, we know that, so they're in a different range, so with whether the methodology catches the higher molecular weights, molecular weight range that can elicit an odor, among other things, I'd be kind of curious what that, it'd be great to piggyback on top of that.
Yeah,
Well, you know, if you want us to, what I'd recommend we go ahead with is, come back to the committee with what we'd like to try first to get a measure of the fingerprint spectrum, how to do that. And we can also figure out how much it would cost.
mhm.
We
Yeah.
could do that.
I think that makes a lot of sense, basically the preliminary groundwork for what we
Yeah, and
effectively did.
and basically, I'm just asking that we have, that the committee feels it's worth pursuing, and then we could take those actions. And if there's money involved, which there probably will be, because people have to do stuff and they like to get paid to do stuff, that we then identify about what that would cost and make the proposal. Now, where the money comes from, like I said, I still feel that we're doing this for the county. We're not necessarily asking the Republic to do it. Where the money comes from is really more or less up to the county commissioner.
Any thoughts, comments on this?
You know, they were talking last night, the planning commission about bandwidth for monitoring and, actually they talked about, DSAC a little bit, so there may be some, interest.
I think there is.
Yeah.
And, you know, PFAS, I think is a very key issue. And we would actually, if we do these, sample collections, based on what you know, are we gonna have enough of a sample to, measure the concentration of PFAS in the emissions? I think we can if we get the right samples.
If you sit on the landfill itself, it takes a couple hundred mils.
Yeah.
Of air, not much. If you're down gradient where a lot of pollution has occurred, that's a different. order
Yes,
of
exactly.
magnitude. So it really depends on where you're at. We didn't have the right instrumentation to do a big screen when we did our PFAS study. We looked for certain target compounds. Of course, that's a bummer because we have so much samples from so many different places from the landfill itself. And then, of course, it'll just dilute from that point on.
But, well, you know, so the point is with, if we're on the landfill, 200 milliliters is not very much, you know, it's not that much. Okay,
Down gradient, you may need meters.
if we get like a 10-meter cube bag, you know, that's big, but that's still quite doable.
I think a
So-
lot of air emissions tend to be stacks, and that's a specialized equipment, specialized approach. Probably optimized, you know, when you get a consultancy that does that, I think it's for stack emissions versus ambient background. I'm not sure there's that much demand for that, so I don't know how commercially available that is. It's a different animal.
I did look up landfill odor detection systems, and there's a number of companies out there. Some have where a
Yeah.
person walks around and, you know, they,
Curious what they actually are detecting.
yeah, what they're able
Because
to.
odor is a very junk term for lots of things. And it's kind of a sweet spot, again, I don't know if you were on the committee at the time. It has to be a molecule that's soluble enough to interact with the mucosal membranes. It has to be volatile enough to be in the air, so that's not that many molecules fit that ability, so it's kind of a narrowish range.
I
But
think some
it's
of
a proxy for a much larger range of molecules that are in the air.
I think they were also just detecting, well, they know some odors, but then I don't know if they do the exact spectrum and say, oh, but where's the fingerprint of molecules are present?
Yeah.
Which is-
Fingerprinting is kind of a newer idea, and the research edge, a lot of people do targets, so a lot of EPA methods are made for benzene, benzene, real prescriptive. But like, as I mentioned, when we were worried about our ability to absorb air on the tube and that our PFAS would be out competing for things like benzene, which is orders of magnitudes higher. That is a carcinogen. That is a carcinogen. NSTOP, that's known. So those levels are very high, so I also worry about, well, now you have this information, let's say you approve the expansion, great, we've got a benzene generator for who knows how much longer. We'll wait.
But the real question really boils down to which you're on is we go out there and sniff something. But if we use the right sniffer, then we would say that is present. We're not saying, we don't necessarily have to say quantities right now. But we can identify and should be identified to say, when we sniffed, it's coming from this direction or that direction.
Right.
So if it is the sanitary soil over there, we can say, no, not here, but what I'm always curious is, you know, I understand that we have an envelope out there, but I'm more concerned if something is migrating like that. Where you're on the perimeter to say, yeah, migration is coming from here, or migration is coming from over here. So I think that's relevant. I think that's what a lot of the citizens are asking too. Is I smell something and I don't know where it's coming from.
Well, that's why it's nice to know where the source is, whether it's the landfill, or ERC, or somewhere else. Those are all three options. And we don't want to blame the landfill for a non-landfill generated odor.
But we just want to say that presence is here.
Yeah,
And and it's coming from this direction. We're not blaming anybody, but there's a relevancy there then that we've identified that is there. Then we can uncover it later.
yeah.
Okay, I'm gonna stop it there because we have a couple of others.
So that's the only request is, are we allowed to go forward with what we just mentioned?
Sounds good to me. Any
Okay,
objections?
you guys?
Yeah, pretty so.
I would say, you might wanna start thinking about what it would look like to have to make it into a grant proposal of some kind, and that includes like covering your bases, like what kind of odor monitoring is done in the county already, yeah. Or air quality monitoring, rather.
I think air quality is more encompassing than odor.
Yeah, air
Yeah,
quality
I
is
agree.
probably a better way to frame it, sure.
So they're focused on odor because that's what people complain about, so they're just trying to get rid of the odor. They don't care about, they're not worried about the carcinogens. You
Yeah,
know,
it has a
they're-
kind of minimizing effect, just to call it odor, it's just like, oh no, you had 6 hours of not pleasant smells in there,
It's gonna get the cancer, that's another. bad-
Well,
Yeah.
I need, let me have one more thing, and then we very quick. So, it's kind of like the fascination I have from this comes back from a history of something called the Love Canal, which is an area that seemed great until people found out what they were living on.
Yeah,
So it's nice for us to find out what we're doing. And it may or may not be dangerous, okay, but it'd be nice to know.
oh, absolutely. I'm just saying, Republic is focused on keeping complaints away, and the only thing they're complaining about is it smells bad.
Yeah.
But along with that bad smell, who knows what else that they don't smell? So I think,
Yeah.
coming at it from an air quality might even have more funding options.
Yeah, like the super emission of the methane, you would never know that.
Yeah,
You
Thanks a
could
lot.
not detect that.
So you lived there long enough, I mean, I remember historically, driven by that going for over 50 years. There used to be a huge open space and you never saw, it. You could see the garbage from the roads sometimes. Now that they have a working face of a few acres, have you detected a change in what you smell in there? Or you may say, what smell, I'll smell.
Well,
I don't hear the train anymore by my house.
yeah, I don't, in the past, I did not smell anything, and I do now. Okay, but that's just one measurement.
Right.
Okay, and that has a lot to do with the location that they're putting things and the airflows.
Okay, all right, so, let's move on to groundwater and leachate, which is Dave and Charlie, right?
And Peter.
Peter.
So Peter and Charlie and I met, and Charlie had distributed that summary. You can hear me, but I didn't, Bailey doesn't have it electronically yet, but we will have it. You all have it, so
It's a survey
that summary that we
summary.
did,
Didn't I already read it?
you read it, and
Yeah.
you've got it, right? So the recommendations,
Yeah, I read that too.
you know what we're talking about.
Yes.
Okay, so with groundwater, and I'll try to be as brief as I can, there is a ridiculous amount of information. And because the groundwater monitoring is done under a DEQ, it's part of their incorporated in their DEQ permit. They have an environmental monitoring plan that's been in place for over a decade. Yeah, so trying to wrap our head around that thing is what we did, and we've all heard about, well, there's arsenic exceedances here and there, and then there's some VOCs associated with the unlined portions and the closed portions of the landfill. And I guess based on our discussions and my professional view of this, after working in it for over 30 years, nothing leaped out of the page like this is a major smoking gun problem in the data. But where I saw my concerns rise anyway, was in the environmental monitoring system itself. So it's fine to collect data and that looks great. Well, is the well in the right spot? Is it deep enough? Are you monitoring for the right things? So that's kind of the approach we took at it, rather than starting to pick at arsenic, which has been picked to death. We looked at the system kind of more holistically. And based on that, we came up with 6 recommendations that we would ask the group today, if you agree with these things. And then the big thing, Bailey, that I'd like to see is, because this is a DEQ program, DEQ needs to be involved with this. So it's different than the odor monitoring. I mean, they're the regulatory body in charge of this, and frankly, this monitoring system is really minimal, in my opinion.
Okay.
Okay. So Republic's gonna hate this, which is okay, and I'm glad to have the discussions with their consultants about this. Or we can. So the six, let's go through the recommendations real quick. The first one is just a well assessment. You know, these wells, some of the wells date back to the 1970s. Most of them are in the 1990s. So these things are over 30 years old. And while there's not a recognized functional life of a well, it depends upon the chemical environment and what, you know, everything else, the geology, the whole thing. I would like to see somebody go and do an assessment of each well and the condition of each well to see how these things are they, is the casing crack? Are they producing water? Is it filled in with sediment? And I didn't write specific things that they should do. I think that's up for their consultant to tell us. But I've done these things before. It could be as easy as running a sounding line down the well, and is it still at the same depth as it was when it was built? Because these things tend to silt in over time. You pull water in, silts come in, and it gradually fills up and starts blocking the screen. So things like that to let us know whether the wells are functioning properly. So that was one of them. That's just on every well. The big one for me was additional wells on the east side. They have two wells that are monitoring between the landfill and Finley. The other well, E. Wilson. Yeah, sorry about that. We like to go birding, so I get it. So yeah, so there's two wells, 26 and 27. Both are high in arsenic. Both are very low yield wells, so they're completed in a clay silt at a depth of about 20 feet. And they have to be sampled by, you go in there day one and you purge all the water out. And because it comes in so slowly, they can't sample it until the next day or two, because they have to let the water run back in because it's in such low permeability unit. And one of the wells, well 26, is right next to that that stormwater pond, Tokatee Marsh. And I remember I shared this with you guys a couple of meetings ago. The hydrographs are supposed to go like this seasonally. You know, it rains, water levels right. That one just kind of goes like this. And when I mentioned that to Tuppen, I had a talk with Eric. I said, dude, what's with this well? He said, it could be connected to the pond. And I'm like, well, yeah. So I don't even know what we're sampling there. Is it groundwater? Is it stormwater? Whatever is a hydraulic influence. And my other concern is that there's this volume of groundwater flowing to the east toward E. Wilson. Is that occurring in that really fine grained, low permeability silt, the bulk of it? Or is
They're going around.
or is it going or beneath it? Or below it?
That's for gravity, that's the way it goes.
Below us is where I'm thinking.
Yeah.
So my recommendation here, and they're gonna just absolutely hate this, but that's okay, is to put in at least one more well on that eastern side. And take a hard look at whether wells 26 and 27 are even at the right depth. 26 in particular. So I think the east side needs a lot of them, and that's part of that well assessment, is this thing even functioning properly. Because I would like to sit and talk with their consultants about this, and I'd really like to talk with DEQ, hydrogeologists about this. It's like, come on, man. You spent 30 years hammering me on my wells. Now it's my turn. So I don't think those wells are sufficient to be monitoring offsite releases toward E. Wilson. Period.
So would you want to put wells in the zone that like municipal, not municipal, sorry, residential wells would be? Because if they're at 20 and if there is a refugee emission at 200.
I'm saying that should be looked at. And the one thing, I went back and looked at the well logs for 26 and 27. So they terminated the well, so they drilled down 30 feet or so, and they stopped in the clay. And then they built their well in the clay. What I would like to see is keep going and find out where that contact is with the underlying basalt. Because that's where you're gonna start to see a lot of offsite water. They've completed them in a low permeability formation that in likelihood is very low transmissive for groundwater flowing outside. It's going underneath it, probably.
Because there's so much water, it has to go somewhere.
It's gotta go somewhere. And it's probably a mound, there's probably a hydraulic mound in that landfill prism. that's pushing that water down and.
Yep.
So that's my first big thing. I went, those wells aren't at the right spot and they're not at the right depth. So that's recommendation number 2. First one was assessment. Number 2 is just take a hard look at that east side, put more wells in, and probably deeper ones. Number 3 is E.E. Wilson. I think there needs to be wells on E.E. Wilson on the other side of 99W. And I think, what did we say in here? Installing several deep, shallow well pairs. I didn't specify. I didn't feel like it's up to this group to say, I want 5 wells or 4 wells.
Sure.
Let them propose it. I just wanted conceptually, that is a wildlife refuge and there's wetlands that are sensitive there and there's no wells on it. Charlie, you reached out to ODFW and didn't hear back.
Just that they referred it from the state level to the local ODFW, and they don't really. I did find that old thing. We won't talk about that right now, but that their initial 2009 plan or something around the wetlands, and that their counts at that time were, not actual numbers of birds. It was so.
Yeah.
We should talk about that at the next subcommittee meeting.
And Dave, when you get closer to that PRC, there's actually signs about contamination. Have you
There
seen
is?
those?
No.
I don't think it
Water?
says what it is. I probably have to go, we went there during COVID because everything else was shut down. But there are definitely signs there. There's things about archaeological. We also know it's that former military base, so we also run the risk of running into
UXO.
leaky unexploded ordinances, but I don't know about that, but like the leaky underground storage tanks. So you do have a former military base that I know, and there's some really interesting signs up and around, and there are some areas where it does indicate some kind of contamination, but it's closer to the PRC. We'll have to know that.
Just a quick question, you said you're in parts of the EEQ, but Republic has to go through a EEQ permit process.
They do.
And that's the time to introduce that in the permit process. Would you agree to say?
That process, yeah, okay, I don't know when that is. That
Well,
permit's active for the, I'm sorry,
Yeah.
till 2030, I believe. I looked at it, it
Mhm.
might be in one of our,
That sounds right.
I think it's
to me.
2030, Kevin. Yeah, I didn't know how to interject it into the permitting process. But I thought as a county, we could just say, hey, DEQ, we've got some concerns, we want to
Mhm.
talk to you. And it's all fine for Republic to be there as well with their consultants.
But they have an open public process at that time to,
I know, but
yeah, but I don't know.
that's a long ways out.
Yeah, but maybe, yes.
That's a
No,
long ways out.
Is,
Yeah,
I mean, is
okay.
Coffin Butte in compliance in terms of monitoring?
They are.
Okay.
That was one of the statements in, we have, this is a 3-page summary. There's like a 7-page larger thing. So they're in compliance. They are meeting all the requirements of DEQ's permit and all of their monitoring plan requirements. I just disagree that,
That's where the balance is not quite right in the sense that if, I guess what I'm saying is if there's enough professional,
I know what you're saying.
yeah, get there, at least put it on the table. is what I'm
I just think this needs to be on the table. And I would love to talk to whoever wants to talk about it, because it just seems like this system is very skinny for monitoring a landfill of that magnitude. And it's based on older wells, back when the landfill was nearly as big. I mean, these are all old wells.
And
I
Dave,
just
you're
think-
not even done yet talking about the Soap Creek
No, I'm
monitoring.
not done with that yet. No,
No.
I'm gonna get to that.
All right.
So, yeah, I just think that this system has been around for so long and that landfill has grown so much, it's high time that somebody take a look at it to make sure that it's what we want as a county going forward, because that landfill is gonna be there for another, to monitor for 30 some odd years after, even after it's closed. Okay, so E.E. Wilson, I do think there should be some wells there, and that's gonna be up to the state of Oregon to allow an access agreement. ODFW and Oregon Department of Environmental Quality to require it. My fourth bullet is abandoned select wells, and that's more of a just, hey, I'm trying to help you out with public services. You've got some older nested well pairs there where they have one borehole and they put two wells in the same hole, and the screen intervals are separated by clay. So you can monitor shallow and deep in the same borehole, which used to be a very common practice about 30 years ago. It is not now because they found that that clay, as the water table goes up and down, dries and shrinks, it cracks, and then you get hydraulic communication between this zone and that zone. I did look at the data and I thought, that's happening here. Just looking at the chloride data, which is a conservative tracer, it looked like it was happening to me. But I think it would be real easy to put a well in one of the holes, or put a pump in one of the holes, transducer in the other one, and pump that one and see if you see a response in the other. Real easy to do. It can be part of that well assessment. And I'm just trying to do them a favor here, because those samples would not be technically defensible if anyone wanted to question them. Having been in lawsuits before, and the first question would be, are those completed to current standards? No. Okay, boom. Just trying to help them out a little bit there with that one.
Is that well number 95 that you were just now talking about?
That's well pairs 1S and 3S.
Okay.
S and D. And I think they're still out there. And again, we prefaced this whole thing with a big giant disclaimer about there's so many volumes of material, and any oversights or misrepresentations are just a mistake, because we're all volunteers spending a few hours a week at this stuff. So the fifth one is Soap Creek sampling. So they do groundwater flowing from the west side of the landfill discharges to Soap Creek, more than likely, okay? And the way that they're testing for this, and this is in the permit, is it's grab sampling with either a clean bucket or a sample container on the downstream side and the upstream side of Soap Creek. Up in the water column, they just lower and spin the surface, and then they take them and then compare them and go, look, there's not a problem. Well, that is very, you wouldn't do that in today's environment. What you would do is you would do pore water sampling in the bed of Soap Creek, because when groundwater discharges, it comes up and it will infiltrate into it'll come up into the creek from the bottom, right? It's not coming in from the top, it's coming in from the bottom. So you will drive these probes into the creek bed and you collect samples up through there. Or you can put passive samples in there. You can just dig a hole and bury them in there and come back in a month and grab them. However they would like to do it. But that means of sampling Soap Creek is not technically defensible at all. Because any discharge, any signal coming from groundwater is going to get diluted out so quickly with all of that surface water coming by, just the relevant proportions.
So, but you were saying, if I understand you correctly, they're doing what
they're doing what they were asked to do, and they're doing it.
So
and they're
what is,
reporting it, and DEQ is saying fine.
so what is
my problem
what is
with
the position of DEQ today is?
That's why I think we need to talk to them. DEQ is grossly understaffed. They're out there fighting, and Peter and I talked about this today. They're fighting the fires that are right in their face. Okay. This thing here is like, okay, they're complying, they're submitting their annual reports, they look like they're done, they're staffed by a professional geologist, the whole thing. But I don't think anyone's really critically looking at this, and that's the role that we play.
Yeah.
It's really critically looking at it. And Republicans say, we're complying, we're not doing a thing. And yep, that's they sure can't do a darn thing about it. That's why I think DEQ needs to be involved somehow. Because they do hold the permit.
Yeah.
Okay, the last one was the analytical program, and this is what Jennifer just talked about, is PFAS. It's been brought up many times, that's why I asked the question, how easy is it to collect groundwater samples and analyze for PFAS? And it sounds like it's very feasible to do. Just to answer that question. And again, they're not gonna wanna do it. Back when I was doing it, the emerging contaminant was dioxins, which is old school, and nobody wanted to do that either. Because what do you do about it? But in the case of the public interest, it just at least answers the question, are they there or not? And if so, there's a problem.
So just one quick question, EPA hasn't set a standard yet.
They have they?
Or they're not even for, I think they were looking at air quality, but not groundwater.
It was being developed, and then what the new administration, I don't think it is, right?
But the
I
first step
think
you're
it's
saying is
slowing
we
down
should
or
at least
on hold.
identify what's there before we.
Yeah, and then that one will be, of any of these recommendations, probably one of the ones that they're gonna dislike the most. And I understand their reasons for that, but I think there's been so many questions raised, and the technology is there to do the analysis, which I was glad to hear. So this recommendation isn't like, they said, well, we can't do that, there's no lab that can get that low. Jennifer will say, well, yeah, there is, actually.
So what we're saying is that the landfill is out there under I mean, it's correct, it has a position in the world to be here, but it doesn't have a position to migrate to other property, correct? So if you're looking for your samples on the edge of the property and it's present,
Wait,
I'm
wait,
not
wait.
quite sure what you're saying with
What did you just say? You said that if there's contamination beneath the landfill, that's okay, is that?
No, what I'm not saying is that, position of the county can be, or DSAC saying, we just want to see where, if there is a presence of it at the, demarcation lines,
Property boundary, yeah.
property boundary. That should be permissible, inside or outside of the DEQ is providing the funding is there, correct?
I think I understand your question, and yeah, it's permissible.
I mean, I guess it's a question of whether
Oh, it's a
we're
Pandora.
requiring Republic to do
Well, I
big
don't
wells
think,
or
I
do
don't,
something ourselves.
I do, well, DEQ, I mean, Republic is, working within the DEQ environment. But what I'm saying is that, it's a Pandora's box, but.
Oh, no, you're fine. Sorry, Chuck, I'm gonna,
Fine.
I wanna make sure that we get to all the subcommittees, but I don't wanna
Yeah.
keep you here late into the night. So, what I'd like to do is propose, we spend 3 more minutes on this, come up with some kind of action plan. And then quickly transition to, the last subcommittee and then get us all out of here by 8:25.
Okay,
everybody okay with that?
I gotta get going.
I'd like to support the continuation of the groundwater subcommittee's actions as stated.
That's great, and I don't really, honestly don't know what the next step is. I do feel strong that DEQ, because Republicans say, look, we're fine, we're in compliance with our permit, and everything I saw is they are in compliance with their permit. I just think the monitoring requirements set forth in said permit are very minimal,
Sure.
based on old wells with an old footprint.
I mean, I think it's worthwhile pointing this out, even just to kind of like lay it all out there before the permit is renewed. And also if they're permitting an expansion, having it out there that they need to do better is also
Yeah, okay.
would be helpful.
So.
Yeah.
So do we just, I think that, it's a great subcommittee, you've done great work, and I'd like to see it continue. Do we need to say that as a team? And we just move on?
Does anyone have any objections to the subcommittee continuing its work?
I thought that was kind of a charter that they to keep nibbling at this.
Yeah, let's keep poking at it. Let's
Yeah.
keep poking at it.
Yeah, I think this is great.
Great,
Yeah,
thanks.
thank you. All right, quickly on to community engagement, which is, someone remind me.
Diane?
Not here, Diane does.
And Robert is.
Robert's here.
I've got,
I'm gonna respectfully bow out here.
Okay, thanks, Brent. Good night.
So I'll be pretty quick. We met with, Julie Jackson, out at Republic and, had a good meeting and, you know, sort of what we're looking to get is like a portal for, you know, getting complaints in and getting maybe information out. And trying to leverage, Republic as much as possible. You know, right now a complaint goes into Republic and it gets dispersed and then it's gone. So, you know, I think if we can, you know, help, you know, if they can tell us a little bit more of a point person and then we can have some sort of portal where you know, we know what's going in, so we can expect a result coming back out and try to, you know, fine tune that. We were just kind of going through and saying, well, what's the current system right now? And so we kind of documented that, you know, you have Republic, you have the EQ complaint form, you have Benton County complaint form, so try to get a single portal where we can potentially, you know, get public input. And then, you know, the elephant in the room is the expansion right now, so sort of once that's over, whether it expands or not, we can leverage, the publicity that's been generated about, you know, the landfill as far as, and maybe even get into the recycling. I know that we talked about that earlier, that might not be DSAC, but, you know, as far as outreach, you know, Republic would love to get, you know, they're sort of big on getting less stuff into the dump and having things sorted properly and whatnot, so. You know, that's something, you know, as far as outreach would go, and then, we just talked about the challenges of, you know, multi-tenant buildings and how do you work through that, so. It's really just kind of a get to know Republic and what's their ideas and how we can, interface with them and just, you know,
Yeah, that sounds great.
Thanks for doing that.
Yeah,
Yeah.
appreciate it. It looks like you're working with Julie.
pardon me?
You're working with Julie Jackson?
Yes,
Yeah,
yeah,
great.
yeah, that's the one, yeah.
All right, well, that sounds fantastic. So, I guess as far as subcommittees go, why don't we all just continue with the plan to meet in the off months? So find a time in August that will work for everyone. And then we'll reconvene as DSAC in September.
The links for the odor, methane, air, and the water groups, those links will remain the same. So you can just use whatever you used last month.
Awesome. All right, well, unless anyone else has anything real quick, I'll entertain a motion to adjourn.
Wait, I'd like to
Yes,
propose one item for next
yes.
meeting. I'd like a report on how the fire safety program is going from the public.
Okay.
You know, we issued the fire proposal
Yeah.
and they accepted it, and I wanna know what they've done.
Okay, so, Bailey, maybe that's a request for Paul, you can give us an update.
Yeah.
Mhm. And I'm hoping at this next meeting, so that'll be what, August? No, September,
September.
when we next meet. By then I'll have the Coffin Butte annual report. So I was also planning to ask Paul to give a presentation on that too.
Yeah, they did mention in the meeting last night, your meeting with them out there and, as far as fire was concerned and they basically just recapped what, you know, your report. There wasn't any mention of any progress or anything,
Well,
but.
I wanna know what the progress is.
Right.
But
Yeah.
then after that, they had an incident where somebody got on site and I think they turned up. I heard them articulate the concern over safety. And that might also include fire because they had that
Security, yeah.
security that might be related to that.
Yeah.
So all of a sudden it became like a really good idea. Because they had this person get on their property and you don't know what they're gonna do. I don't know if it involved fire, but if they
Yeah,
fire
so-
them up.
Yeah, so let's hear how they're doing on
Yeah.
what they've done to up their.
Yeah, they sort of bragged about it, so it'd be kind of nice to
Yeah.
see what they actually did.
Well, maybe we can give Paul some early notice, so. they
Okay.
haven't-
Yeah, I've already, that hamster has been running in my head already.
If anyone else has any suggestions for agenda items, just email me and Bailey, and we'll see if we can work it in. Anyone want to move to adjourn?
Move to adjourn.
All those in favor? All right,
Thank you
thanks
so much.
everyone. Good night.
So thanks, have a good trip.
Yeah, yeah.
Maybe we can
So,
meet at your place
That'd be good.
next time if you happen to be around.
It'd be a lot easier than.
I'll make that revision.
Yeah.
So I'm taking off like
I'd like
early in
to
the morning, so
also go up the hill and see stuff.
unless you wanna change that
That'd be cool.
for the five to six
You know,
and get it.
finding what's for
You've got, you doing that?
I'll send it to
Bailey.
That'd be.
So it'll be coming from
What's that?
Peter.
I'm gonna send you just a little
Yeah,
minor update to
approximately.
this.
Oh, perfect, thank you, great. Yeah, and I will be in touch with you as well on the
Which,
DEQ person.
I don't know how to do that. I don't know how to like contact him and we probably get ignored.
Yeah,
Whether to go to Republic first
Oh.
and say, here's what we're thinking.
hmm
That's a good question.
And-
It's bummer tickets, yeah.
They won't like it.
I would like to have it.
Yeah.
They're gonna say, well, we're applying for the permit.
You look at your
Sure are.
schedule.
yeah,
So I don't know how to heads up with them.
When she buys
Yeah.
her ticket, how close are they
Yeah.
in compliance?
I'd like to have it on.
Like if you
Tuesday.
take out the questionable wells.
They're in compliance.
Okay.
They're in compliance.
Uh,
In
so I
that
see if I can
permit,
got this too.
in that permit.
There we go.
like, give me a-